So let's meet our MIcrobit. A MIcrobit is a pocket-sized computer that can be coded to perform a variety of tasks, and you would have learned a bit about coding from Methane and maths. So a MIcrobit contains 25 LED lights, and these help us to visualise some of our data. So be paying close attention to those in our experiment. It also has an A button and a B button, and again we can code these to perform different tasks. On the bottom we have 5 pins, so we have a 0, a 1, a 2, a 3 volt and a ground, and these are where we connect our crocodile clips later on. On the back there's lots going on, but there is space here for an accelerometer and a compass, a processor. We have ports for a USB as well as our battery pack. We turn it over here, we can see that more clearly. So again, space for our USB and for our battery pack. And this is important because we need to power on our MIcrobit before using it in our experiment. So when attaching our battery pack, please do so carefully. It is probably one of the easier ways to damage our MIcrobit. So just be gentle when you're doing this, so when you're connecting it and also while you're disconnecting it. When we do have power, we'll be greeted with a little monster face, so we know it's working. A few things to keep in mind when we're working with our MIcrobit. Typically we try to hold it by the edges. We keep it clean and dry and make sure it's not resting in any water. We don't place any metallic items on top of it. And a big thing to just be careful of is to not connect the 3 volts and the ground pins together. This is a safety thing, so just please make sure you don't do that. Overall, our MIcrobits are a really fun new way to bridge the gap between physics and chemistry and instrumentation, and we really do hope you enjoy this experiment. So we're going to look at how to actually set up our MIcrobit and our conductivity probe next. Okay, so let's set up our MIcrobit and our conductivity probe. The first thing we have here are 4 wires, and each wire has 1 crocodile clip on top and bottom. Next we have a breadboard, and on this breadboard we have a 56 ohm resistor. Of course we have our MIcrobit here. And to power our MIcrobit we have a battery pack with 2 AAA batteries. And finally we have our conductivity probe. So this consists of 2 copper wires in a plastic sheet that was actually 3D printed in the physics lab. So let's go about assembling this. The first thing we need to do is apply power to our MIcrobit. To do that, we can place the port of our battery pack into our MIcrobit gently, and when we have power we will see this lovely little monster face pop up on our MIcrobit. The next thing we're going to do is build our circuit. So we have a wire here with crocodile clips. The colour doesn't matter, all the wires will do the same job. So we're attaching 1 crocodile clip to one end of our copper wires, and the other crocodile clip of this wire goes onto our resistor. And I'm making sure it's just firmly in place there. Next, I'm going to take another wire, and using crocodile clips I'm going to secure it to the other side of our resistor, just like so. The end of this wire is going to be attached to the ground pin of our MIcrobit, so that's the last pin you see here. And I'm just making sure all of these pins are aligned and they're nice and secure. Next, I'm taking my green wire here, and this wire is particularly special because it's going to be connected again to the same side of the resistor as our yellow wire. And this one is going to go to P1. And the purpose of this wire is to measure the current that's actually flowing through. So this is what will give us our voltage level value later on. And finally, to complete our circuit, I'm taking my red wire. One end is going onto the other copper wire of our conductivity probe, and we're completing our circuit by attaching this to P0 on our MIcrobit. So now we have built our conductivity probe and we can now complete our experiment. So what's going to happen next? Well, you have created a series of solutions of sodium chloride ranging from 0 grams per litre all the way to 10 grams per litre, and we can test the conductivity of these. To do so, what we can do is take the solution of interest, about 50 ml in a beaker is plenty. This is just our 2 grams per litre of sodium chloride here as an example. We can take our probe and just submerge it and hold it in place for a few seconds. When we're ready, we can press the button A on our microbit, and a voltage level reading will appear on the microbit interface. And this is the value that you record in your results table under voltage level. So the microbit doesn't actually record conductivity as your traditional or your commercial conductivity probe does. It measures voltage levels instead. So when we want to convert from voltage levels to the units of conductivity, which today is a microsiemen, we will use a factor to multiply by. So every value you get for your voltage level, you will multiply that by 150 to give you your conductivity value in microsiemens. So that's our setup. Give it a go and see how you get on.